Let's look at the solution now. If x is equal to 2 raised per 100, y is equal to 3 raised per 75, and z is equal to 5 raised per 50, then which of the following relations is correct? Okay. Given that the bases are different, in case I want to compare them, the best way would be if I can make their powers equal. I see 175 and 50 have 25 at HCF. So I'd write it as 2 raised to the power 4 raised to the power 25, 3 raised to the power 3 raised to the power 25, and 5 square raised to the power 25. Here I get 16 raised to the power 25, 27 raised to the power 25, and 25 raised to the power 25. Between the three of them, I know y is the largest, and the second largest is z, and the third largest is x. So option C. Next question. Find the sum of the digits of 100 raised to the power 10 minus 10. Okay. Can I write this as 10 raised to the power 20 minus 10? I can take out 10 common. I'll be left with 10 raised to the power 19 minus 1. Now 10 raised to the power 19 means 1 followed by 19 zeros. So effectively a 20-digit number, from which if you subtract 1, will you get 19 nines? 9999, 19 times. And this whole thing is multiplied by 10. So 9999 19 times, even if it is multiplied by 10, the last digit will become 0. That doesn't really change the sum of the digits, no? Sum of the digits will be given by 9 into 19, which is equal to 171. Is this correct? Yes, this is correct. Moving on. Golu and Chotu, who are two brothers, share a herd of X cows. They take the cows to the market and sell each cow for rupees X. Okay, so if they had X cows and they sell each cow for rupees X, can I say the total money that they have generated, total revenue generated by them is X square. Revenue generated by them is X square. Okay. All money is either in rupees 10 notes or rupee 1 notes. Okay. One at a time, they take out rupees 10 notes. The brother who draws the first also draws last for rupees 10 notes. Okay. So the brother who draws the first. So if he, let's say brother 1 got first note, brother 2 got second note, and he got the third note also, and this stops here. Let's say this stops here. So, or even if it continued, they stopped here. Or let's say they continued, they stopped here. Effectively, they're selling me 10 rupee notes. 10 rupee notes. The total number of 10 rupee notes that they had was odd. Total number of 10 rupee notes that they had was odd. Okay. The second brother complains about getting one less 10 rupee note. Cool. Which is also confirmed by the fact that 10 rupee notes were odd. So the first brother offers him all the rupee 1 notes without taking any. Okay. So the first brother, because he had an extra 10 rupee note, he tells the other brother, you take all rupee 1 notes, I will not take any. The second brother still received a total less than the first brother, which means rupee 1 notes were less than 10. If rupee 1 notes were more than 10, then brother 2 would have received extra money. But it says the second brother still received a total less than the first brother. So rupee 1 notes was less than 10. Okay. So he asks the first brother to write him a check to balance things out. What should be the amount in rupees to be paid by the check? Okay. Now, fun thing, given that these two brothers are trying to divide the money equally, can I say this number will be even? This number will be X square will be an even number. Only then can they divide the entire amount among themselves equally. Okay. If this number is even, can I also say an even perfect square is a multiple of 4? An even perfect square is a multiple of 4. Yo, keep both these things in mind, because if x square is even, the unit digit can either be 0 or 2 or 4 or 6 or 8. Because it is even, unit digit can be these. But given that it is also that it is a perfect square, can the unit digit be 0? Yes. Can the unit digit be 2? Can a perfect square have unit digit as 2? No, this is out. Can a perfect square have unit digit as 8? No, this is out. Cool. Okay. Next thing, we are told that the tens digit, whatever amount of money they had, the tens digit here was odd. Number of 10 rupee notes were odd. So tens digit is odd. So either the tens digit was 1, 3, 5, 7, or 9. Similarly, 1, 3, 5, 7, or 9. And 1, 3, 5, 7, or 9. Can you see? Because this had to be a perfect square, this case now becomes unacceptable. It had to be a perfect square and a multiple of 4. If it was 1, 0 or 3, 0 or 5, 0 or 7, 0 or 9, 0, this is not a multiple of 4. Similarly, 1, 4, 3, 4, 5, 4, 7, 4, 9, 4 is not a multiple of 4. The only case where you are getting a multiple of 4 is this one. So the total number that you have is a perfect square ending in 6. So you can go ahead and assume x to be 4. You can go ahead and assume x to be 6, or you can assume x to be 14, or x to be 16. Whatever you choose to do. Can you see? I'm working with x equal to 6. The total money is 36 rupees. Brother 1 got 10 rupees. Brother 2 got 10 rupees. Brother 1 got 10 rupees, and all 10 rupees are used up. And now brother 2 got the 6 rupees. Now in order to balance it all out, what should be the amount to be paid by check? How much should he pay to brother 2 so that they get balance? The balance has to be 2 rupees. If total was 36, both of them should get 18 and 18. He already has 16, he has 20. So he'll give 2 rupees to brother 2 and our work is done. Let's say we have worked with 36. We have currently worked with 36. If we were working with, let's say, 16, we are working with a huge number. So can I say there will be 25 10 rupee notes? So the first brother gets 13 into 10 rupee notes and the second brother gets 12 into 10 rupee notes. Then he gets all 6 rupee notes. He has got 130. He has got 126. Sorry, not 0, 126. Again, he has to pay how much? Rupees 2 only. So answer to this question should be option C, 2. What is being used here is property of it being x square and it being a multiple of 4. That enables us to reduce our work. Moving on. This is an amazing question. X, Y, Z are 3 distinct natural numbers such that x is less than y is less than z. The only factors of the number, x plus y plus z are x minus 7, x plus 6, x plus 9, y minus 10, y plus 5, y plus 1, z minus 12, z minus 7, and z plus 20. These are the only possible factors. So I'm just listing it all out. X minus 7, x minus 6, x plus 9, and y minus 10, y minus 5, y plus 1, z minus 12, z minus 7, and z plus 20. Can you see? We have total 9 factors. Which means this here is a perfect square. And not only is this a perfect square, among all the factors listed, can you see z plus 20 is the largest factor? Z plus 20 is the largest factor because z was greater than y was greater than x. So using x, this is the largest factor. Using y, this is the largest factor. And using z, this is the largest factor. 20 is greater than 1, 20 is greater than 9, and z is greater than y, z is greater than x. So this is the largest factor. Can I also say this is equivalent to the number itself, or z plus 20 is equal to x plus y plus z, or what we now have is x plus y is equal to 20. We have this result guaranteed. X plus y is equal to 20. If we have identified the largest factor, let us also see who can potentially be the smallest factor. Can this be the smallest factor? Z minus 12? Yes. Can this be the smallest factor? Yes. Can this be the smallest factor? Yes. We have three cases. When these could be the smallest factors. Additionally, for any natural number in the world, the smallest factor is what? Is 1. Is 1. So let me now make cases. If z minus 12 was 1, it would mean if z minus 12 was 1, it would mean z is equal to 13. So the total that we would have is 33. Is this an unacceptable case? Because we know x plus y plus z had to be a perfect square. X plus y is 20. If I take z equal to 13, total will turn out to be 33. So this is not. So now I know z minus 12 is not the smallest factor. Let me put x minus 7 as the smallest factor. If x minus 7 was equal to 1, then x will be equal to 8. X would be equal to 8. If x is equal to 8, if x is equal to 8, y would be equal to 12. Now see the list of factors that we get: x minus 7, 1, x minus 6, 2, x plus 9, 17, y minus 10, again 2, y minus 5, 7, y plus 1, 13, and we'll worry about everything else later. Can you see the wonderful thing? Y minus 10 and x minus 6 turn out to be equal. These now this is impossible. This is impossible because then we'll no longer have different factors. We will no longer have 9 factors, then we will have less than 9 factors. So this case is also unacceptable. So this is also not the smallest factor. If this is not the smallest factor, then we know for certain y minus 10 is equal to 1. If y minus 10 is equal to 1, y is equal to 11. Y is equal to 11 and x is equal to 8. We know y is equal to 11 and x is equal to 8. So, sorry, not 8, x is equal to 9. So the list of acceptable factors for our number x plus y plus z would be 2, 3, 18, 6, 12. These would be the acceptable list of factors. Now, let's find out the LCM of these factors. The LCM of these factors, the lowest common multiple for these factors is 36. And remember, our original number had to be a perfect square. So let's see if x was equal to 9 and y was equal to 11 and z was equal to 16, so that the summation turns out to be 36. Does that ensure that these three terms remain what they are? Z minus 12, so 16 minus 12, this will give me 4, yes. Z minus 7, this will give me 9, yes. And z plus 20 is of course 36. Yes, everything figures out, everything settles into place appropriately. So the precise value of x is 9, precise value of y is 11, and precise value of z is 16. The question is asking me, which of the following statements is true? X is a perfect square? Yes. Y is a prime number? Yes. Z is a perfect square? Yes. So answer has to be option D, all three of them. It is a wonderful question. If you did not get it in one go, I would implore you to go back and rewatch the entire explanation all over again. There are steps to this. Amazingly, wonderfully thought out question. Next question. If fn is equal to n into n plus 1 by 2, where n is a natural number, what can we say about the value of fn plus 1? Okay. So fn plus 1 will be equal to n into n plus 1 by 2 plus n plus 1, n plus 2 by 2. You take n plus 1 by 2 common, you're left with n plus 2, which is as good as 2n plus 2. You take out 2 common, you cancel this, effectively you're left with n plus 1 whole square. What can be said about the value of fn plus 1? Answer has to be always a perfect square. That is all for today's episode. Hopefully you learned something. That will be all. Okay, bye.